Good afternoon, dear students. Today we are going to discuss about the um, sweet ion structure of amino acids. So far till yesterday we have discussed definition of amino acids and different types of amino acids, their classification based on the number of acid groups and basic groups, based on the position of the amino group, and also based on their activity, that is essential and non-essential amino acids. Today I am going to teach you another important topic in amino acids, that is sweeter ion structure of amino acids. Sweeter ion structure of amino acid. Now we know the general formula of amino acid is, all of us know that the general formula of amino acids, that is NH2 CH2 C double bond O OH. They are containing both acid group and basic group. In solution, when you add these amino acids, suppose if you are adding these amino acids in solution, in solution will be existing as a charged molecules. This, if you add this amino acid in solution, they will be, or amino acid in solution will be acting as a charged molecule. The main reason for the amino acid to act as a charged molecule, because the amino acid is containing mainly two groups. One is acidic group and another one is basic group. That means the same molecule contains both acid and base, both acid and base. This is the reason why these amino acids in solution are existing as a charged molecule. So what happens, why they are having a charge means, that means the amino acid will be carrying both positive charge and negative charge. What is the main reason why these amino acids in solutions are acting as a charged particles? Here, the main reason for the amino acids to act as a charged particle, the main reason for amino acids to act as a reason is proton transfer. Proton transfer. How this proton transfer is taking place, we will see here. The proton transfer takes place as an internal acid-base reaction. Okay, so we will see first, write a general formula of amino acid. That means you have alpha amino acid. Alpha amino acid, that is, suppose if you have R, CH, C double bond O, OH, and this has NH2. NH2. All of us know this. Though we write in this way, there is a bond between the oxygen and hydrogen. So now what happens? Oxygen is more electronegative than the hydrogen, and here nitrogen is carrying two lone pair of electrons. Suppose oxygen being a more electronegative, attracts the bond pair of electron towards itself. So what happens? H will be existing as H plus. H plus. Here the lone pair of electrons in the nitrogen have the capacity to attract this H plus. So H will be remaining as an H plus, and the lone pair of electron in the nitrogen will be attacking this. So as a result, you will be having a Switter ion complex, that is RCH. Automatically the lone pair of electrons from the nitrogen is attracting the hydrogen, that is H plus. So automatically it will be carrying a NH3 with a positive charge, and C double bond O minus. So you can see here this amino acid is carrying one side negative charge and another side positive charge. So this is called Switter ion. The product of this reaction called Switter ion or dipolar ion. This is known as the Switter ion or dipolar ion. Dipolar ion because it is carrying two charges. It is carrying two charges. So that is what Switter ion. Once more, in solution, amino acids are existing as an charged particles. Why they are able to exist as a charged particle? Because amino acids are containing both the basic group and acid group. Because of this, there is a proton transfer is taking place. That is an internal proton transfer is taking place. The oxygen, which is more electronegative, will be attracting the bond pair of electron towards itself. Here H plus, H remains as an H plus. Nitrogen, which is having a lone pair of electron, has the tendency to accept this proton. So as a result, you have a product in which one side there is a negative charge and one side there is a positive charge. So in the same molecule you have two charges, that's why it is called dipolar ion or Switter ion. So a Switter ion is an amino acid molecule containing both positive charges and negative charges. In solution, Switter ion will be in an equilibrium state. Nothing is permanent. So that is the arrow here. It is showing, this arrow means it is an equilibrium. Equilibrium. There is a shift from one side to the other side. Another important topic which I want to deal with you today itself is that isoelectric point. Okay. Another important topic is one is Switter ion and second one is isoelectric point. Isoelectric point. Amino acids in Switter ion form is an amphoteric nature. Okay, amino acids, the Switter ion, if they are existing as an Switter ion, they are amphoteric in nature. That means amphoteric in nature. What is this amphoteric in nature? They will be reacting with both the acids and bases. They will be reacting with both the acids and bases. So that is called amphoteric in nature. Why they are able to react with both acids and bases is when an acid is added. Suppose you know that a Switter ion only is amphoteric in nature. So what is the Switter ion? We already know what is the Switter ion here, isn't it? So what is this Switter ion? We will be seeing. When acid is added, so there is a Switter ion. All of us know what is Switter ion. That is, you have R, CH, NH3, positive charge, and again you have CO minus negative charge. So this is a sweeter ion. When acid is added, we all of us know acid means a species which is able to provide H plus ions is called an acid. So any species, for example like HCl or H2SO4 or HNO3. Okay, so for example, if you add any of these acids, these are strong, one is HCl is very strong acid. That means it is able to provide or furnish H plus ions in the solution. So what happens when it is providing H plus ion? This H plus ion will react with O minus. So there you will get an amino acid. What type of amino acid are you going to get here? RCH, C double bond O, OH, and here nitrogen will be having as usual positive charge. So it is a cation, the positive charge species. In the same way, suppose if you add base, this is addition of an acid. It is addition of an acid. Same way, if you add base, addition of base. What is base? Here H plus ions are provided. Here addition of base. That means OH minus ions are there. So for the same molecule, again you add base, that is OH minus. What happens? OH minus will abstract a proton from here. NH3 you can write as NH2 and hydrogen. So OH minus will be abstracting this hydrogen. Then as a result you will be having RCH, NH2 and CO minus. So it is anion. To sum up what is happening here, in acidic solution, amino acid exists as a positive cation, and in that means it will be attracted towards the negative electrode. In base it will be existing as an anion. It will be attracted towards the positive electrode. At a certain pH, what is happening here we will be seeing. At a certain pH, the concentration of the cation 1 may be exactly equal to the concentration of the anion. Where these both at a certain pH, when these concentrations become equal, there will be, so at certain pH, the concentration of the cation 1 may be exactly equal to the concentration of the anion. Hence at that pH, there will be no resultant migration of amino acids in an electric field. Such a pH at which an amino acid does not migrate in an electric field is that isoelectric point of that amino acid. So what happens if they both are constant, if the anion and cation at certain pH, the concentration of anion will be equal to the concentration of the cation. So what happens? There is no migration. If one is excess, suppose if anion is great, If anion great means it can migrate towards the negative electrode. If cation is great, it will be migrating towards the positive electrode. But if they both are same, there is no migration. There is no migration. So the pH at which there is no migration, the pH at which an amino acid does not migrate, is called isoelectric point of that amino acid. At isoelectric point, the concentration of the Zwitter ion is maximum. Here, the concentration of the Zwitter ion will be maximum. Okay, so the isoelectric point is an individual characteristic of amino acid. That means each amino acid will be having a different isoelectric point. It is a unique identity of that particular amino acid. Okay, and it depends upon the basicity of the amino group and the acidity of the carboxylic group. For example, for glycerin, it is 6.1. Phenylamine, it is 5.5. Glutamic acid, it is 3.2. So for each amino acid, each amino acid will be carrying a unique isoelectric point or unique pH. Okay, for alanine it will be different, for glycine it will be different, and for glutamic acid it is different. And this pH is always depends upon the basicity of the amino group and the acidity of the amino group. So this is another important points which you have to remember in your classes. Okay. Now this is one session.